Project 3.2.1, CHUMP Code, Clock, and Counter. This is the start of a 4-bit computer built entirely out of chips and assembled on a breadboard called a cheap, homebrew, understandable minimal processor, or CHUMP for short. The original computer designed by David Feinberg will consist of a program counter, program EEPROM, and a custom-made program that is stored inside. Power is supplied through a barrel jack that was built in the previous video and regulates power to 5 volts through voltage regulator. This project consists of 2 parts, each controlled by an individual electric circuit linked together through a clock pulse. The clock portion of this project is built off of Ben Eater's clock build that was shown in class and consists of an astable and monostable 555 timer with the option of an automatic or manual clock pulse. The two can be switched together through at will with the use of a toggle switch. Like all other processors, the CHUMP's heartbeat is a clock signal that is adjustable through the input of a potentiometer to control it to reach the ideal speed required when in astable mode. When in monostable mode of the clock, a push button drives the clock line, which allows you to control the pulse of the clock one button push at a time and can be very helpful for the debugging process. The next part is a program counter circuit consisting of the SN74LS161 program counter and the SN74LS00 that keeps track of what line number the program is on through its binary output. It rises for 1 by 1 for every pulse of the clock and it goes back to 0 after it reaches 15 due to its 4-bit output restraints, demonstrating why the CHUMP program can be a maximum of 15 lines in length, counting 0. The third and final part of this project was a piece of code written in Chumpanese in David Feinberg's virtual CHUMP machine. For this part of the project, I chose to write a piece of code that would add together 2 numbers, starting with number 1. Start by loading 1 into the programmer, and then add 1 to that number. After it did that, it would go back and add 1 to the same number that it had just created, and so on.